Okay, hello and welcome to math. Let's do corrections for recap 6. Again, there are two versions of every page, so there's either the 6A or 6B version of the page. So just skip ahead to whatever is most relevant for you. So the 6A solving, problem 1. So what I'd like to do here is try and do the way most people did it. And the vast majority of people here tried to clear out the fractions by multiplying through by the common denominator, so 15. So you just have to make sure that you're multiplying by every term. So this whole thing is a term, which means we can distribute within it. Same thing here, this whole thing is a term, so we can distribute within it. So when we multiply, I'm going to do it like this. I'm going to say we get 15 times, let's move all of this over here just so it's a little easier to deal with. 15 times 1/5 equals 15 times x plus 2 over 5 minus 15 times x minus 7 over 15. So in the cases where I have the 15 on the top and the bottom of the fraction, like here, I can see that 5 is going to divide into 15 3 times, so my result there is just going to be 3. Here, I'm going to distribute my 15 to each of these. So in the first case, I'll get 15x, and in the second case, I will get 5 dividing into 15 3 times. So I'll get 3 times 2, right? Because the 5 will have divided out. I think for the purposes of being able to read this afterwards, this might be easier to read as, if I do it in two small steps, 15 times 2 over 5, and then I'm going to take 5, divide it in, and then we have that, and that's how we get our 3 times 2. Minus, and then I'm going to distribute here my 15. Well, I'm not actually, so here's what I'm going to do. I'm going to write it as 15 times, and on the top, it's going to be 15 times x minus 7, and I could distribute it if I want, but on the bottom I've still got 15, so I can divide out both of those 15s. Now, the tricky part comes next. I get 3 equals 15x plus 6, and then it's minus x minus 7, like that, which means, but I have to remember this because I'm subtracting x and I'm subtracting negative 7. So what happens there is I get 3 equals 15x plus 6, and then it's minus x plus 7. So this is the key part that tripped most people up. So 15x, I'm just going to combine like terms. So on this, I'm going to minus 6 minus 7, which is minus 13 here. And I'll get 10 equals 15 minus 1 is 14x. So x equals 10 over 14, which means x equals 5 over 7 when I reduce my fraction. Okay, so again, the challenging part was here. That was sort of the crux of the problem. This turned out to be a very doable problem. I was so excited by the way people did it. So most people actually did this distribution here first, so we get 3x minus 6 equals 11 over 2 minus 17x over 6. And then most people chose then to multiply the whole thing by the common denominator that was 6. And I loved seeing all of the arrows showing what they're doing. So 6 times 3 is 18x. 6 times 6 is negative 36. This is 6 times 11 over 2 minus 6 times 17x over 6. So these 2 goes into that 6 3 times. This 6 goes into that 6 1 time. So we'll end up with 18x minus 36 equals 33. That's 3 times 11 minus 17x. So let's add 17x on both sides, and let's add 36 on both sides, and we'll get, 35x equals 69, 33 and 36. So x equals 69 over 35. And on we go. Okay, the 6b version, similar but different. What most people wanted to do here was multiply everything through by 8. Actually, let me talk about the parens first. So it's fair to say that these parentheses here are sort of meaningless. In other words, if I rewrite the function or the equation as this, it's still exactly the same thing, right? Still fine. In other words, the parens didn't do anything. If I distribute this positive sign here, it's just plus 2x and plus negative 3 halves. It doesn't change the sign on the 3 halves. The other thing you have to notice here is that this minus sign here really means that whole thing is being subtracted, that group that's on top of the fraction. And that'll be important to remember. So what most people would do here is multiply by 8. I love seeing them draw in these arcs about what they're multiplying. So then you end up with 8 times 3 over 4 plus 8 times 2x minus 8 times 3 over 2 equals negative 8 times x plus 2 over 8. We're going to divide that out, so that's just 1. We're going to divide the 2 into the 8, and we get 4. And the 4 into the 8, and we get 2. So here we get 6 plus 16x minus 12 equals negative x plus 2. And I purposely didn't distribute yet because I wanted that to show up as my next step. And this is what most people missed. Again, really kind of the crux of the issue there. So let's rewrite it. 6 minus 12 is negative 6. Oops, didn't mean to be in red there. Negative 6 plus 16x equals minus x minus 2. Minus x minus 2. So I'm going to plus x on both sides and plus 6 on both sides and get 17x equals 4. So x equals 4 over 17. And we're done. Okay, next one. This turned out to be relatively easier for people. I was super excited by it. I think the vast majority of folks chose to do this distribution first. So they got 8 minus 4x plus 5 over 3 equals negative 7x over 6. And then once they did that, they then chose to multiply through by the common denominator, which is 6 here. So I get 6 times 8 minus 6 times 4x plus 6 times 5 over 3 equals 6, whoops, I forgot the negative sign, negative 6 times 7, whoops, that should be black, 7x over 6. And then we can divide this out. That's 1. 3 goes into 6 2 times. And now we've got 48 minus 24x plus 2 times 5 is 10 equals negative 7x. So let's see. Let's add 24x to both sides. And though this was not very good looking, but it is a plus. So we get 58 equals 17x. So x equals 58 over 17. And on we go. Okay. So here I'm going to first lay out the points that I see to use. I can clearly use here 0, 1. Notice also, actually let me move that real quick. I want to put it on the other side. Notice also that the slope here is over 1 and up 3. So we have a slope equals 3. And here, and so what it means is down here when I look at all the equations down here, anything that has, so normally normally y equals the absolute value of x has a slope equal to 1 or negative 1, depending on which side of the graph you're on. So when we do this here, these all have slope of 2. And these here all have a slope, I guess that's a slope of 3, and there's a slope of 2. These all have slope of 3. So if we're looking up here at the very first one, it's a slope of 3. So I'm only interested in the pink ones. And then I can plug in this point here, 0, 1, and see if it works. So when I plug in 0, and I get, in order to get out 1, it's this equation. So b of x equals 3 times absolute value of x plus 1. You can check that here. Imagine 3 times the absolute value of 0 plus 1 equals 1. So that's my point 0, 1, which works. Okay, over in the next graph, I have again here, so I have a slope of 3. And so I'm only interested in the pink ones, and the question is, which one? So it has to be that when I plug in negative 3, I have to get out 0. Well, that's going to happen here at c. I plug in negative 3, I'll get 0. So c of x equals x plus 3. Whoops, forgot my slope. There. And we can see when we plug it in, we get 0 does equal 3 times negative 3 plus 3. And down here, for the first time, we have a slope of 2. And when I plug in 2, I need to get out 3. So when I plug in 2, I need to get out 3. So imagine here, plugging in 2, I get 2 times 3 is 6. 2 becomes 6. Here when I plug in 2, 2 times 2 is 4, plus 1 is 5. Here when I plug in 2, I get 2 times 2 plus 3 is 10. Here when I plug in 2, I get 2 times 2 minus 2, that's 0, so I get 0. So far, I'm not getting out my 3 that I wanted. And here, when I plug in 2, I get, whoops, sorry, that should be 2 times 2 plus 2 plus 3. 2 times 4 is 8 plus 3 is 11. So I've got to say none of the above here because nothing worked. All right, on we go. Okay, let's notice here, notice something. Normally, if we just have y equals the absolute value of x, we have a slope of 1. And so in these cases, here, 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 and here, we have a slope of 3. And conversely, or differently, when I see a 2 out here, these all have slope of 2. So that helps us cut down all these graphs here. So first thing I notice about this one here is over 1 up 2, I have a slope of 2. And then I also know that this point down here is at 3, 0. So when I put in an input of 3, I need to get an output of 0. So do I see that somewhere? Ah, look, here's what I see here. 3 minus 3 is 0. So that's 3 times 0, which is 0. So that seems to work. But it doesn't have a slope of 2. Oop. But slope is 3. Over here, I have 2 times 3 minus 3 gives me 2 times 0, which is 0. So 3 gives me 0 here, and it has a slope of 2. So that's my answer. For the next one, I'm looking here again, over 1 up 2, so I have a slope of 2, and I know that this point is 0 has to put in and get out negative 3, and that's only going to be h of x. 2 times absolute value of x minus 3, and I'll check it. 2 times 0 minus 3 equals minus 3. So I put in 0 and I got out minus 3. Put in 0, got out minus 3. I'm going to go back up here. Yeah, and just put in 0, got out 1. Put in negative 3, got out 0. Okay, so people can see that. Now down here, look at what I notice. Over 1, up 1. So I have a slope of 1. And none of my equations have that, so it's got to be none of the above. On we go. Okay, given this, find a of 3. So the big issue here, again, is this is my input. So a of 3 means my x becomes 0. So in other words, this 3 replaces that x and that x. So square root of 5 minus 2 times, I'll do it in pink, 3 equals square root of negative 1, but that is not possible. And what it means is the point, not what I wanted to write. What that means is on the graph, x can never be 3. Okay, when x is negative 2, same idea. A of negative 2 is square root of 5 minus 2 times negative 2. So that's square root of 5 plus 4, which is square root of 9, which is 3. Don't forget that the plus sign there. Sorry, I need a little bit of tea. I'm losing my voice. Ah, boy, that's good. Okay. We've talked about this a little bit in class as well as it having been on previous recaps. Find x. So I need to find x. I need to find the input when a of x, my output, equals 0. So that's when 0 equals the square root of 5 minus 2x. Well, if we decided to square both sides, square root can definitely be 0, so we can square both sides and we get 0 equals 5 minus 2x, so 2x equals 5, so x equals 5 over 2. Find x when a of x is 6, so that's the same thing. Square root of and 5 minus 2x. Here I'm going to, again, square both sides. Squaring undoes square root, so we have 36 equals 5 minus 2x. So subtract 5 from both sides. We get 31 equals 2x, so, negative 2x. Don't forget the negative sign there. So x equals, let's, whoops. I wanted an eraser. I didn't get it. I hate it when it does that. And you have to I've got to fix that. Here. Delete. Okay, so let's divide by 2 on both sides. Divide by negative 2. Negative 2. And then x equals negative 31 over 2. On we go. Okay, given this function, we realize that this 2 becomes the input now, so it's going to go where that x is. So 2 goes there, and it goes there. So b of 2 means square root of 4 minus 3 times 2, which is square root of 4 minus 6, square root of negative 2, which is not possible. And what does that mean for the graph? That means that x is never 2 on this graph. We just can't put in an x of 2. It doesn't exist on the graph. We'll find that the graph goes a bunch of other places, but never touches x equals 2. When b of 0 then means very similarly 4 minus 3 times 0, which is easy enough to do. That's just square root of 4, which is 2. Okay, find x when b of 0. So remember, this is our input, and this whole thing is our output, also known as x and y. So we want to say, we start with b of x equals square root of 4 minus 3x, but we're replacing that with 0. So 0 equals 4 minus 3x. We are going to square both sides, because the square root can definitely be 0, so we have a legitimate thing here. We have 0 equals 4 minus 3x. If we add 3x to both sides, we'll get 3x equals 4. So x equals 4 over 3. Find x when b of x is negative 4. So negative 4 has to equal the square root of 4 minus 3x. Unfortunately, the square root function can never be negative. Otherwise, it wouldn't be a function, because we'd get 2 different values. If you remember your square root function graph, right, it looks like this, and the graph looks like kind of like that, right? Always positive. Has a domain of x greater than or equal to 0. Okay, on we go. Find the y-intercepts. So the y-intercept is when x equals 0. So we're going to check there. So f of 0 is 0 squared minus 5 times 0 minus 6. So f of 0 is minus 6. So that's our point, 0 comma minus 6. This is also when x equals 0. So we'll have y minus 2 equals negative 2 times 0 minus 1. So y minus 2 equals negative 2 times negative 1. Y minus 2 equals 2. And then we will add 2 to both sides. Sorry, I got the hiccups there. Y equals 4. Oh, I shouldn't be circling that as my answer, because it means y equals 4, so our point is 0 comma 4. That's my answer. X-intercepts are when y equals 0, so that's f of x. So 0 equals x squared minus 5x minus 6. So let's put it in factored form first so that we can use the zero product property. So factored form for this would be 0 equals x minus 6, x plus 1, which means x minus 6 equals 0, so x equals 6, or x plus 1 equals 0, so x equals negative 1. So our points are going to be 6, 0, and negative 1, 0. This is all a little bit too big. Let's shrink it just a tad. Ah, come on. It shrunk and then it didn't shrink. I don't know why it does this. There we go. Okay. So this is also when y equals 0. So we have 0 minus 2 equals negative 2 times x minus 1. So minus 2 equals, and let's distribute here, there, and there. So minus 2x plus 2. Don't forget that's negative times a negative. So let us subtract 2 from both sides. And we'll get negative 4 equals minus 2x. Divide both sides by negative 2 because those went away. And we get x equals 2. Oh, again, don't box that. That's not our answer. So it means our answer is 2, 0. And the point or points where they intersect. So let's write down our function. So what we want to know then is there's some point x comma y that works in both equations. Well, I've already got y equals x squared minus 5x minus 6 for that bit. But this thing, I think I would like to rewrite as, well, let's do it here. Y minus 2 equals minus 2x plus 2. And then add 2 to both sides, and I'll get y equals minus 2x plus 4. I don't know why it suddenly thinks I'm doing fitness now. That's just so weird. Apple. Anyway, now we've got, I don't know, math is hard work. We've got two functions. So we want the two y's to equal each other, which means this equals this. So x squared minus 5x minus 6 has to equal minus 2x plus 4. So whatever x value makes this statement true is where they intersect. So let's solve this. So plus 2x and minus 4, and we get x squared minus 3x minus 10 equals 0. And so now we're going to, again, we're going to get factored form and then use the ZPP. So factored form here is x minus 5, x plus 2, which means that either x minus 5 equals 0, so x equals 5, or x plus 2 equals 0, so x equals negative 2. There's a whole bunch of people that don't write that down. I don't understand why. They're just trying to be fast and cool. To me, it's kind of more lazy. And when they don't write it down, they oftentimes screw up the sign on the answer. So when x is 5, we can plug this. I'm going to write note over here. Now plug into one of the equations. To get y. So y equals minus 2 times 5 plus 4. So y equals negative 1. So one of my points here is 5 comma negative 1. Did I get that right? That feels funny. Oh, no. Color. Negative 10 plus 4 is negative 6. Duh. And so one of my points is 5 comma negative 6. That's this one. And my other point comes from plug in this, y equals 2 times and negative 2 plus negative 2. Orange. Negative 2 times negative 2 plus 4. Well, plus that should be an orange. So y equals 8. So this side over here means my other point is negative 2 comma 8. So there's one, there's the other. I might see if I can shrink this down a little bit. Let's be patient here with me, folks. No. Undo. And I'm gonna arrange to say, whoops, don't do that. Okay. There's the 6b version. The y-intercepts happen when x equals 0, so we're putting that there and there. So f of 0 is 0 squared minus 5 times 0 minus 14. So our point is 0 comma negative 14. And again, where x equals 0 here, we get our y-intercept. So y minus 9 equals minus 0. Paren problem there. minus 0 minus 9. Notice then that this negative sign means that this is going to be positive 9. So y minus 9 equals positive 9, and then we'll add 9 to both sides. It was really easy to get messed up on the negative signs here, and we get y equals 18. So our point is 0, 18. Okay, the x-intercepts happen when y equals 0. That's this. So we'll have 0 equals x squared minus 5x minus 14. And what we're going to do is we're going to get factored form and use the ZPP. So 0 equals, what is that? X minus 7, x plus 2, which means x minus 7 equals 0, so x equals 7. So that's 1, 7 comma 0. Or x plus 2 equals 0, so x equals negative 2, and so negative 2 comma 0. And those are our two x-intercepts. Oh, no, come back here. Not sure how that happened. Same idea over here. It happens when y equals 0. So we're going to plug that in there. We get 0 minus 9 equals the opposite of x minus 9. Remember that you need to distribute this here and here. So this becomes, negative 9 equals negative x plus 9. So let's subtract 9 from both sides. And we get negative 18 equals negative x, which means x equals 18. So our point is 18 comma 0. Okay, the point are points where they intersect each other. First off, I don't like that written that way. So I'm going to rewrite this in y equals mx plus b form. So I'll get y equals minus x minus 9 plus 9. Then I'm going to do my distribution and get y equals minus x plus 9 plus 9. So y equals minus x plus 18. So this is one equation. My other equation obviously is this y equals x squared minus 5x minus 14. So that's my other equation. So we want the two y's to be equal to each other, which means that x squared minus 5x minus 14 has to equal minus x plus 18. And that's because the x value that makes this true that produces the same point on both graphs. If it produces the same point, that's where they intersect. So let's combine like terms. Plus x and minus 18. And what we get is x squared minus 4x. Let me get to my notes here. That feels funny. No, that's right. X squared minus 4x minus 32 equals, that sums to 0, that sums to 0, 0. So now we're going to get it in get factored form and use the ZPP. So we'll have x minus 8, x plus 4 equals 0, which means either x minus 8 equals 0, or it means x plus 4 equals 0. Which means x equals 8, or x equals negative 4. And now we're going to plug these into one of the equations to find y. So here I'm going to use that. So y equals minus 8 plus 18. So y equals 10, which means my point is 8, 10. And on the other side, I'll have y equals minus negative 4 plus 18. So that's y equals 4 plus 18. So y equals 22. And our point is negative 4, 22. And we're done. Have a delightful day.